Hi everyone, welcome to the session of matrices and vector with Python. In the previous session, we have learned about a type of matrices and two of the types we have not covered, which are the orthogonal matrix and the singular matrix. Let's start. And before that, we'll see what is orthogonal matrix, and then based on this, we will do some hands-on on Python. Now, first of all, an orthogonal matrix is a square matrix whose columns and rows are orthogonal unit vectors. Alternatively, like if we multiply the matrix to its transpose, and the output is an identity matrix 1001 or 100010001 if the dimension is 3, then the input matrix is orthogonal matrix. We can say that the matrix into its transpose or the transpose of matrix into the dot product of the same matrix is identity matrix, then it's a case of orthogonal. Vice or else we can also say the transpose of matrix is equals to its inverse. Then also we can say that it's an orthogonal. So what we will do in our code, we will test three things. First of all, we'll check that the example where the matrix is not orthogonal. Then we will see that the matrix is orthogonal for unit vector, and again we will see for the randomly chosen matrix we will show that it is a orthogonal. We will import numpy, and after that we will create our normal matrix is equals to np.random, and then we'll create elements from 0 to 9 and 0. We will give 4 comma 4 is the dimension. Okay, then we'll simply print the matrix. Now what as per the we'll find a matrix transpose. Okay, now the rules: transpose of a matrix, the dot product of the matrix and its transpose should give a identity matrix or a unit matrix. Okay, so we'll see print matrix dot. Okay, so this is not a case of orthogonal matrix. Now what we will do, we will take one unit matrix. So unit matrix, so we can see the matrix and its transpose will be same because it's a case of unit matrix. And now we'll simply print. So now also it is like it is giving the output of the unit vector. So this is an orthogonal matrix, but this is a very easy to show that a unit vector like a unit matrix is an orthogonal matrix. We will see the real example where we will generate a matrix, randomly chosen matrix, and based on that we will show whether it's a orthogonal or not. So for that what we'll do, we'll from scipy dot stats import ortho group. Okay, and then we'll create a matrix is equals to ortho dot rvs. This is a method which I have taken from GitHub, and also the reference is present in Stack Overflow, so I have taken it from here. If you are interested, you can also go and do a further research. So rvs, and we'll give the dimension is equals to 4, and after that we'll give simply print our matrix. Now then what we'll do, then np dot will do set print options to be suppressed true. Now after that what we'll do, we'll print the transpose. Okay, here m dot and then m dot t. Okay, we have not executed this, so we'll execute this. This is some matrix which is generated here, 4 by 4 matrix. Okay, and after that we will execute this. So you can see 100 0100 0010 so this is an identity matrix. Now after this, now as per this, alternatively what I have said, that if we multiply the matrix, like alternatively if the transpose of a matrix is equal to its inverse, then also it can be termed as an orthogonal matrix. So what we will do, we will get a transpose of the matrix, yeah, right, and then we will get the inverse. in this way also, both the matrices are same. The inverse of matrix is equals to its transpose. So hence we can say that this is a orthogonal matrix. So we are done with orthogonal matrix. Now, what is a singular matrix? Well, a matrix is called a singular matrix if the value of its determinant is 0. So we'll start with the singular matrix. So in this case, there are two scenarios we will check. The first scenario will show that determinant is non-zero, and hence it is not a singular matrix. The second case, which will show that determinant is zero and hence a singular matrix. First of all, we know that determinant of a matrix is only possible if it's a square matrix. If a matrix you want to check whether it's a singular or not, what we will do, calculate the transpose of a matrix and then we'll multiply it with the original matrix, and then we will find out the determinant. That is how, if that product, the dot product, the value of the determinant of that dot product is 0, then it's a singular matrix. It's not, then it's a non-singular. So transpose dot simple matrix. Okay, so we will evaluate this matrix. Okay, so we have this matrix. Now if we want to see whether this is a singular matrix or not, so it is a not non-singular because the value is greater than 0. Now what if we want to show, like, we can, I want to show you the example how we can create a scenario for singular matrix. For like, singular matrix is directly related to dummy variable trap, which I have already printed in one of my sessions. I will be giving the link. Okay, so what we will do, we'll create a matrix. Okay, matrix np dot the identity matrix 3 comma. So here identity matrix of 3 by 3 is created. After that we'll create one more matrix 1, which is equals to once. It will just create a matrix of 3 rows and 4 columns. Everything will be 1. Here everything is 1. After that, what we will do, we will update the first 3 columns of matrix 1 with matrix. Executing this, see, initially it was 1 1 1 1 1 1 1. Now the identity, the first 3 column is nothing but the matrix, which is identity matrix, and the fourth column is like 1 1 1. Now after this, what we'll do, just we will np.linalg.determinant and will get the dot product, okay, of the transpose of that matrix with the original matrix, and make sure the transpose path should always come first. Okay, here it should come matrix 1. We are calculating on matrix 1, not on matrix. Okay, so you can see the value of the determinant is 0. So if you want the in-depth knowledge of how it is happening, I will provide the link of the dummy variable trap in my Python for machine learning, which I have where I have explained it very clearly how the dummy variable trap scenario is set, and the root cause of this is the singular matrix, how it is set. And one more thing, in my previous session I have shown about, like, explained about the null matrix, where the null matrix, suppose matrix is equals to np.np empty will not work every time. 2 comma, if we give this, so instead of this, if you want to create a null matrix, like what I have shown here for a null matrix, somewhere I have shown, yeah, np.empty, and it was not working, like sometime so what we can do, instead of this, what you can give, np.z are zeros, and here you provide a shape, np.zeros, and here you provide a shape is equals to 2 comma 3, suppose. Now if you execute this 0 0, now you change the want to give 10 10